Now, I don't know anything about quantum computers. I'm learning about it on my own. And that's my take on how it is, from what I read and what I developed from my background and my interests and retention and forte, which I had none of. Right, Joe? Good. Joe Rutkowski, Rotterdam. That's in New York too, right? It's close to Albany. I've been there a few times. I passed there a few times, I remember. So now, how would a quantum computer be faster? Now remember, you see that stack of notes at NASA. One woman did the program for an early flight, and the programs are printed out in a room there. Now the computer itself will be faster because it's designed to clock faster. How would it solve problems that cannot be solved using classical computers? You can break the problems into 1,000 problems and solve all 1,000 simultaneously. And when you end up with a solution, insert the appropriate numbers, like y is equal to mx plus b. You'll have something like that. Then you put in the numbers and you get the roots. I didn't say it right, but you should get the idea. Right? So instead of a subroutine, you will have a subroutine. You will have maybe 50 main programs for 50 different main problems in this type of solution. You use so-called dummy variables, or things that you would eventually replace by what the real problem seeks. But in the meantime, you will use, I think they call them dummy variables. I don't know if that is true or not. Now, if you divide that problem into 1,000 problems and you run it all at the same time, it will be 1,000 times faster, because a quantum computer can run all 1,000 at the same time. Right? Right? I think that's what it is. That's why it's a quantum computer. Now you have 1,000 zeros and one in each qubit, not just a 0 or a 1. You have to have 1,000 zeros and ones that are correct. Can you do that?